been talking to them this week about their work. So today in the 4x4, Mark, take it away. We're talking wildfires.
Yeah, we're talking wildfires. You know, we look at these fires from a distance with the aerial cameras, but we have scientists taking a very close look, a very scientific look at these fires. And Dr. Craig Clement from San Jose State University Meteorology, also the head of the Fire Weather Research Lab. Thanks for coming in today.
Thank you. It's great to be here, Mark.
So we're going to talk a lot about the rag fire in a little bit. First, though, just to give us a better idea of what your group does. It's a pretty unique program, right? Not too many groups out there.
Yeah, we're the only meteorology department that has a fire weather research team and focus on research.
And so it's basically a group of students and basically master's students.
Master's students, undergrads, and we have a postdoc researcher and myself.
And as far as you see the pictures there with the group there, you also have some pretty powerful tools as well to measure the different changing weather conditions out there as well in relation to the fire. Is that right?
Yeah, we're the only team that is certified to go to wildland fire incidents, and we're a national resource, and we can be ordered up by incident managers.
So that truck is basically equipped with all sorts of different weather sensors?
Yeah, what you see on there is a Doppler LiDAR. It's like a weather radar, but it uses a eye-safe infrared laser beam, and it's able to scan the plume and get detailed information about the winds around the fire and of the actual smoke transport.
So when there's not a major wildfire happening, what you guys go on what it's called experimental fires, is that correct?
Yeah, so we set a lot of experimental fires that where we place instruments in the field,
okay,
and allow the fire to burn through.
Okay, they can see that happening right there. That's basically a prescribed fire, and with that you're deploying lots of sensors out there. It's safe to say you're kind of flooding the fire zone with the sensors.
Exactly.
And you're measuring what changes in pressure?
Pressure, temperature, humidity, and three-dimensional winds. So we measure the vertical winds and the horizontal winds.
And so those sensors are right above the fire. The flames they're
actually in the fire. They're actually designed at San Jose State, and you can see the tower in the back where we're measuring the winds and the vertical velocity of the wind, so the updrafts of the column.
And just from my own knowledge, a lot of times when a fire happens, I'll look at the winds around a fire, maybe 10, 12 miles an hour, but you have actually documented much stronger wind speeds within the fire zone itself.
Yeah, it's actually that the winds are 2 to 3 times greater at the fire front than they are at the around the region. So that's a pretty interesting fact that we found.
Yeah, that's good for fire crews out there as well. So this is something you wanted to show us.
Yeah, here's a rotating column of a smoke plume, and just a few minutes before this, the plume was not rotating. So the initiation of rotation in a plume is a lookout situation for firefighters, because this is like the onset of a fire whirl or a fire tornado. But this is much larger, and it has very strong winds. It's almost like a tornado.
And so you're studying all sorts of different wind measurements as you go.
Yeah, with the LiDAR, we're able to scan through that and get a slice just like a radar.
And so that was a fire from last year?
Yeah, that was in Central California in June of 20.
Okay. And that brings us to the rag fire. Of course, we've been talking a lot about that over the past day. Yesterday at this time, we were saying it's 25 acres. Now it's exploded in size to over 6,000 acres. And you have a team out there right now, is that correct?
Yeah, our mobile LiDAR is there with 2 researchers.
And you're probably getting a lot of information in from this fire. Any observations so far?
Right now, they saw the plume that went up, punched through the inversion layer, but the marine layer is actually keeping the winds a little bit lower and humidity high, so it seems like they might be able to get a good jump on the fire.
So you think there's, at least scientifically based, there's a good opportunity to fight this fire in the short term?
Yeah, I think I think this is a good example of what we see a lot in California with the marine layer and fire behavior.
And you were talking about the spotting as well as as far as the embers going a long distance to start any fires.
Yeah, so one of the problems with this, because it was a wind-driven fire, if you looked at some of the imagery from last night, you saw that the plume was laid down and really tilted over, but it's also causing spots, and a spot is an ember